Welcome to question 7, the last question in this exam, which starts from a bit of completing the square down through simultaneous equations and finishes up with an inequality question. So let's get started. And the first thing I'm going to do with this is I'm going to put these terms in what I call the right order, with the highest power of x on the left hand side and the constant on the right hand side. That just makes it easier for me to view. I don't know if it's the same for you guys as well, but that's what I'm going to do. And the second thing I'm going to do to make it kind of oversimplify it for myself is I'm going to take out a minus at the start as well, so that I get an x squared plus 10x, leave it at that, and then plus 4, so that I can use completing the square in the method that I'm familiar with, rather than trying to incorporate minuses into there, which is likely to be confusing. So what do we do for completing the square? Well, we've got to take this 10 here, cut it in half, and then take away the square of what that is, which is going to be 5. So we have a minus here, leave that alone. We're also going to leave this plus 4 alone for now as well. So then we're going to have x plus 5, that's half of this 10 here, all squared, so that's in this form here. And then what we need to do is take away this number squared. You always take away that number, whether this is a plus or a minus. So take away 5 squared, which is 25, and then that plus 4 stays there. And the next step is to times it all out, or consolidate the terms, if you like that terminology. So minus x plus 5 all squared plus 25 plus 4, so plus 29, and the last step is just to put it into this order. So we're going to have 29 minus x plus 5 all squared. So p is 29 and q is plus 5. So that's that question dealt with reasonably swiftly. So hence write down the equation of the line of symmetry. So what does this one here, what does this tell us about what our curve looks like? Well, it's an x squared, we know that from this up here. It's a negative x squared. So what it's going to look like is, let's say we just had a normal minus x squared. That would look something like this here, like a normal x. This is a minus x squared, like a normal x squared, but flipped over around this. This is the x and this is the y, you know this. So this would just be flipped over. So this plus 5, unintuitively, the plus 5 tells us that this whole thing is going to be shifted to the left by 5 units. And it also tells us, this 29 tells us it's going to go up by 29. X doesn't follow the rule, so you'd expect plus 5 to be to the right by 5. Y does follow the rule. So our line of symmetry is going to be x is equal to minus 5, because it's going to be a line down here because we've shifted to the left. That's going to be our line of symmetry. So let's move on to question B, part 1, part I, in pink. So we have these two equations. We have points of intersection. Points of intersection means simultaneous equations. So we have a curve C, which is this, and a line L, which is this. So we have the two y's here, which are the same. So let's make these two equations equal to each other. Let's do that over here. So we have 4 minus 10x minus x squared is equal to k times by 4x minus 13. So let's times out the brackets, I think, first. So leave this left hand side alone for now, and then we're going to have 4kx in alphabetical order minus 13k. And then what we'll try and do is, because it's put to us like this, let's try and get everything on the left hand side with this x squared at the start. So we've got a minus x squared, then we're going to have minus 4kx minus 10x, and you can cross these off as you do them, you cross these off like this. So minus 10x, then minus, or plus, let's go with plus 13k, then plus 4 is equal to 0. And then we have to, first we have to times by minus 1 to get this into the positive x squared that they are after. And then after that we have to put these things in brackets. So let's go one step at a time. So we're going to have a positive x squared plus 4k x plus 10x, then minus 13k minus 4 is equal to 0. And then let's group our terms together. So we're going to have x squared that looks like that. And then if you can already see this here turning into this, then that's fine, you don't really need this step. But what I'm going to do is I'm going to say plus 4k plus 10 amounts of x, and then minus 13k plus 4, and then we just have one step left. I'm going to go down a little bit here, and we have one step left, which is to take 2 out of this. So we can say x squared plus 2 amounts of 2k plus 5 amounts of x, then minus 13k plus 4, that is equal to 0. That is a lot of work actually for 1 mark, but never mind, we deal with what we're given, we don't get to choose that. So these two curves, this curve and this line, intersect at 2 distinct points. So now show that this is the case, this here. So this question isn't actually very specific in what they're asking you, but they're effectively asking you the same thing as when they ask for real roots. Real roots means the b squared minus 4ac part of the quadratic equation. If this part here is positive, then you have 2 real roots. If it's positive, then you have 2 real roots. And if it's negative, you have 0 real roots. So in this question, they're saying, are there 2 points of intersection? Well, they're telling us there's 2 points. Show that there's 2 points. So we have to say that b squared minus 4ac is going to be greater than 0. It's going to be positive. So greater than 0. So let's show that. Let's prove that. We've got our equation. Let's go down a little bit and have some space. Let's draw a line under that. Pick another colour, I think. So here we have our b, and well, let's start logically with a. So a is going to be 1 because we have 1x squared. Then b is going to be 4k plus 10 amounts of x. 4k plus 10, I did that before. And c is going to be equal to minus 13 minus 13k, I should say. Let's undo that. Undo. Minus 13k minus 4. Don't be tricked into thinking that that's positive 13k plus 4. So let's have a look at what we've got. So we have b squared, which is going to be 4k plus 10 all squared. It's important to take your time with this, by the way. This question gets very messy very quickly. So 4k plus 10, then minus 4 times by 1, which is 4, times by minus 13k minus 4. So we have to prove that this is greater than 0. So let's go back to purple. Let's times out this bracket to start off with so that we get 16k squared, and then 4k times by 10 is going to be 40k. We're going to have 2 of them, so it's going to be plus 80k, I believe, yes. And then 100 squared is going to be plus 100. Now here, whatever method you choose to go ahead with this, make sure you are very, very thorough about what you do. It's very easy to slip up here. It's been designed so you'll slip up there. So what I'm going to do is minus 4 times by minus 13, which is going to be plus 52k, plus 52, and then minus 4 times minus 4 is going to be plus 16. That's all greater than 0. Now I'm going to try and consolidate. I'm going to try and put all my terms together. So we're going to have just 16k squared, there's only one of them, you can cross that out now. And then we have 80 plus 52, which I believe is plus 132k, plus 132. Then we have plus 116, and that's going to be greater than 0. Then I think we can divide everything by 4. If we divide everything by 4, what are we going to get? We're going to have 4k squared plus 33k plus, that's going to be 29 is greater than 0. There we go, that is the same as, if I go back up so you can see, that is the same as what we were aiming for there, for those 3 marks. So that's all we have to do. That's, you know, we got told to go there and we went there and we've got it. So now solve this equality. So what we just worked out, solve it. Solve the inequality. So let's do that. It's very helpful to draw this out as well, actually. That'll help us tremendously. So let's draw a line under that. And then what can we do? Well, we can solve it like we would a normal quadratic, as if we had x's there instead of k's. K's try to, you know, make it seem daunting, but it's the same in reality. So if you don't know how to do this, this may not help you particularly. I'm just going to go through it because of time restrictions, as if you do know how to do this. To get this into 2 brackets, that's going to be greater than 0, and then we have our 2 brackets, 4k plus 29 times by k plus 1. It's all going to be greater than 0. So then we have our 2k values, our what they're called critical values, or critical points even sometimes. So they are going to be minus 29 over 4, and the other one is going to be minus 1. So if you imagine, we have our positive k squared, I guess you could call it, k squared. So here we go. So imagine this is k, and this is y here. This is y. So what we have here is 2 points. This is going to be our minus 29 over 4, and this is going to be our minus 1. And we have some function that comes down that looks roughly like an x squared, like this, something like that. And we have to note down, where is this function greater than 0? Well, it's greater than 0 on this part here, all of this up to infinity, and everywhere from minus 29 over 4 down to minus infinity. So what we need to say is that this function is greater than 0, so let me write this down. 4k squared plus 33k plus 29 is greater than 0 when k is less than minus 29 over 4, or when, doesn't matter, or and when k is greater than minus 1. That is when this function here is above the k-axis, I suppose you could call it. That is the end of this video. That's the end of this exam. I hope you found these videos very helpful. See you on the next one.